Here, this 10 is 2 times 5, 2 times that 5, and this one's 5 squared. In other words, if I divide this by 2, I get 5. If I square it, I get that one. In fact, that's how we recognize these. Remember, when we factor these, we could use trial and error or the grouping method, but I always also told you, if it's a perfect square, remember, this is a perfect square. This is what we looked like how I wrote it on that strategy, that handout I gave you, the strategy for factoring polynomials. We said this a plus b quantity squared is a squared plus ab plus 2 ab's plus b squared. There's a relationship. The square root of this one was a, because it was a times a, so the square root would be a. This came from b times b, so it's the square root of that's b. The middle term was the a and the b multiplied together, doubled. Notice the square root of this one's x. Square root of this one's 5. 5 times x doubled is the 10x. But look at the relationship between those two numbers. If we take half of that one and square it, I get that one. Even if it was a minus, see, it was x minus 5 squared, then it would be x minus 5 times x minus 5. And if I multiplied it out, I get foil it, I get a minus here, a minus there, that stays a plus, because we'd have negative 5 times negative 5, or two negatives multiplied together. So we get minus here, that would still be a plus, and a minus there. I guess you couldn't see that, but if you multiplied x minus 5 times x minus 5, we get two negatives here, a negative there, a negative there. Otherwise, it's pretty much, it's kind of very close to the same. The only difference is a negative sign here. Still, half of negative 10 is negative 5. If you square it, you get that. Okay, so let's talk about a method called completing the square. And notice, if we can get something like this, we can factor like that. And that means that we'll have, I don't know where I put that one page now. Yeah, then we'll have, see, if we have something like this, that's kind of like that. And maybe we can solve it using that square root method. So this is called completing the square. Now you saw the relationship between this number and this one. So if I said, hey, we have x squared minus 10x, let's say, and I asked you, find the number that you can add on to these two terms to make this a perfect square so it factors like this. We just learned what the relationship was with this specific example, but it always works out like that. It's always like this. So what we're going to do is take half of this number, half of 10 or negative 10, it doesn't matter which one you use because you're going to square it. Take half of it, multiply by 1/2 or divide it by 2, and square it. That's negative 5 or 5 squared, it wouldn't matter, 25. This is the number I got to add on. So if I put a 25 right here, if I added it on to x squared minus 10x, I made this into a perfect square. And it factors like this. This is how simple it is to factor. Take the square root of this. It's always going to be a 1 in front of this the way we're going to do it. So it's always just going to be the letter. Goes here. Take the square root of 25, or half the 10, which is 5, and put it there. And use this sign, minus. If this was a plus, I'd have a plus there. Let's say another example. Let's say we have x squared, let's say plus 14x. And I ask it again to complete the square, to find a number to put into the box here to make this a perfect square so it'll factor as a binomial squared like that. I want you to find the number that goes into that box. Okay, by what we just learned. Now we want this to be a 1, which it is. So take half of the 14, divide it by 2 or multiply by 1/2, and then square it. That's 7 squared, 49. If you add that on, that's a perfect square, and it factors like this. X, either half of 14 or the square root of 49, which is 7, Both of those will be the same. And use this sign right here, plus. If you FOIL this back out, you'll get that. If you FOIL the x minus 5 squared, you'll get this. Let's say we had make it a little more complicated. Okay, find the number to add on here to make this into a perfect square. So it factors like this. It's a fraction, so what? Do the same thing. Half of this number. So you multiply 1/2 times either -3/4 or 3/4, because it won't matter. Remember, dividing by 2 is the same as multiplying by 1/2. It won't matter whether you use the positive or negative, because you're going to square it anyway. So we get 1/2 times -3/4. 1 times -3 is -3. 2 times 4 is 8. Square it. Now that means -3/8 times -3/8. That's -3 times -3, 9. See, it's always positive because you're squaring it. And 8 times 8 is 64. So that's what I add on. That's what I put in the box here, 9/64. And this now is a perfect square. That means I can factor it like this. X, whatever that letter is squared. Remember, there's going to be a 1 in front of there. So you just use this letter. Take the square root of this, in other words, x. It's just x. Then take the square root of this. Square root of 9 is 3. Square root of 64 is 8, so it's 3/8. Or multiply that by 1/2. 1 times 3, 2 times 4 for the denominator, 3/8. But 3/8 goes here, and use this sign. If you multiply this back out, x minus 3/8 times x minus 3/8, FOILed it, simplified it, you'll get this. Okay? That's simple. So that's how you complete the square. Now on the in the book on page 694, they kind of have the method you use. Multiply, we'll read it anyway at the bottom of the page, whether you have the ebook or not. And then you have a bunch of examples of how to choose the appropriate number to add on. Okay? Okay, let's try to solve this one now. That one, by completing the square. Let me show you how to do it now, by using this method. Okay, so solve this one. X squared plus 6x plus 1 equals 0. And let's say solve this one by completing the square. Use that method. By completing the square. Okay? Okay, when you solve by completing the square, you have to do two things first. It doesn't matter the order. One thing, you want the coefficient of the squared term to be 1. I want this to be a 1. It already is. If that was a 2 or something, I'd divide everything by 2. The other thing you want to do, and you can do this one first or second, is to put the constant, if there is one, on the other side. So this is already a 1. That's the way I want it. Now I'm going to subtract 1 from both sides. So we'll have, on the left side, the 1's subtract out, we'll get x squared plus 6x. On the other side, we get equals -1. I put that space there because I'm going to add a number to the left side. Okay, now we're going to find that number that completes the square of the left side. So we're going to find that number as it goes in that box. Because this is an equation, if I add it to this side, and you always add it, don't ever subtract it, you always add it, but because it's an equation, I have to add the same thing to both sides. Now, how do I get the number that goes in there? As long as this coefficient's a 1, which it is, we already checked that, we take the coefficient of the x term. 6, or, it's positive 6. Multiply it by 1/2 or divide it by 2. So 6/2, or 1/2 times 6, which is 3. Square it. That's 9. So we add 9 on the left side, add 9 on the right side. The left side now is a perfect square. It's going to factor like this. We just went over how to do that. So it's going to be x. Take the square root of that, or just use that letter. either the number here is either square root of 9, which is 3, or half of 6, which is 3. It'll be the same thing, whichever one you do. And then use that plus sign there. If you multiplied this out, foiled it, you'll get that. And then on this side, we simplify. -1 plus 9 is 8. Notice that now it looks kind of like that one that we did a minute ago using the square root property. See, the variable was in one place in this grouping symbol, so we could just get put the 1 on the other side, so we get this squared base with the variable on it, the square of that base, and then a number on the other side. And then we can take a square root of both sides to get rid of the square and get to that letter we want to solve for, that variable. So let's do that now. Let's just use the square root property now. So just take the square root of both sides, and we get x plus 3 equals, now don't forget the plus or minus. Some students do. Square root of 8. Square root of 8, let's simplify it over here. That's square root of 4 times square root of 2. We know how to do that. That's 2 times the square root of 2. So we end up with x plus 3 equals plus or minus 2 times the square root of 2. We want to solve for x, so let's subtract 3 from both sides. Now, as I showed you before, you can put minus 3 behind, but we usually don't do that. We're going to subtract 3 from this side. We're going to put the minus 3 in front. These subtract out, so we get x equals -3 plus or minus 2 times the square root of 2. Remember, that's two answers. That means equals, one of the answers is -3 plus 2 times the square root of 2, and the other one is -3 minus 2 times the square root of 2. You can write it like that too if you want, but either one of those is fine. Those are the answers. You can check them. Now, I'm not going to do this all the time because it takes some work, but let's check one of them. Let's just pick this one, see if it works. Let's see if it's right. So let's check that one. Check that answer right there. So the original problem is this. There's the original problem. Let's substitute that -3 plus 2 times the square root of 2 into the problem. I put it right here for that x squared plus 6 times that -3 plus 2 times the square root of 2 plus 1 equals 0, question mark. Now we got to square that. Let's do it over here. You got to FOIL it. So we have -3 plus 2 times the square root of 2 squared, which means this. I'm going to maybe skip a few steps, we'll see, but first times first, -3 times -3, that's 9. Then outsides are these two, that's -6 times the square root of 2. Insides, that's also -6 times the square root of 2, 6. And then last times last, that's plus, because they're both pluses. It's 2 times 2, 4, times square root of 2 times square root of 2, 2, or 8. So it's 9 minus 12 square roots of 2. These are like radicals. -6 more, plus 8. 9 and 8 are 17, right? So we have 17 minus 12 times the square root of 2. That is this thing squared. So I'm going to replace this right here with that. You can't see it, but it's 17 minus 12 times the square root of 2, and then plus, I'm going to distribute the multiplication here. 6 times -3 is -18, so let me just make this -18. And then 6 times 2 times the square root of 2, so all positive, so plus. 6 times 2 is 12 times the square root of 2. I distributed the multiplication, then plus 1. Question mark, does that equal 0? -12, or subtract 12 square roots of 2, add 12 square roots of 2. Those add up to 0. 17 minus 18 is -1, plus 1 is 0. Worked out. It's an answer. This one would also work, but I just checked that answer. Okay. And I stole that one from the book because I knew it came out reasonably nice. Here, let me steal another one from the book here. Let's solve this one. What is it? 2x squared plus 4x plus 3 equals 0. Okay, let's solve this one. Now, you could try to use the factoring method, but this one wouldn't factor again. I leave it to you to check that, but it would not factor. So we're going to, the only other method we know now is, we know how to solve by factoring when we can factor this side, which we can't here. We know how to solve using the square root property when it's in the proper form. This one isn't. See, there's an x squared and an x. There's two different terms with x's in them, and they're not like terms. So we can't use that. So let's use completing the square again. What do we do? First two things we do. It doesn't matter which one you do first. I want the constant on the other side. I just want x's on this side, and I want a 1 to be multiplied by x squared. Let's move the constant over first. Let's subtract 3 from both sides. Then we have 2x squared. See, these 3's cancel out. They subtract out. So we have 2x squared plus 4x equals negative 3. Now I want this to be a 1x squared so I can complete the square. So I'm going to divide both sides by 2. So I multiply both sides by 1/2 or divide by 2. That just means divide every term by 2. That's all I'm going to do. So divide this by 2, divide this by 2, divide this by 2. Divide every term, though. Both sides get divided by 2 or multiplied by 1/2. This becomes 1x squared plus 2x. I'm going to leave a little space for plus my box because I got to figure out what to put in there. Then I have negative 3/2 on the other side. And I got to add the box on that side too because I got to add the same thing to both sides. Okay, now I'm going to complete the square. Remember what we do. We go to the term that, look at the coefficient of the x term, the x to the first power term. It's a 2. So I take the 2 and I multiply it by 1/2 or divide it by 2, which makes it a 1. Then I square it, which is still 1. So I'm going to add a 1 in both of these, put a 1 in both of those boxes, add 1 to both sides. Okay, this side now is a perfect square. It factors like this. See, x, square root of 1 or half of 2 is 1. Use that plus sign. That's simple. If you want to check it, just multiply back out. You should get that. Now we have negative 3/2 plus 1. I'm assuming you can do that in your head, but 1 is 2 over 2. Let's write it like that. So we have negative 3 plus 2 over 2. That's negative 1/2. Okay, now we can use the square root property because I have a term on one side that's squared with an x in it inside the grouping symbol here and a number on the other side. And notice it's negative. That means we're not going to get real answers. We're going to get a complex answer, an imaginary answer. Okay, let's take a square root of both sides to undo the square. So we get x plus 1 equals. Now, some students write this. That's not correct. It's plus or minus. Remember, there's two things you can square and get negative 1/2. Let's simplify this side. So just take the square root of negative 1/2. Let's just move the negative out of there and write it as a square root of 1/2 times I. Remember, we said we can do that. Then square root of 1/2 is a square root of 1 over the square root of 2, because it violates the fraction underneath here, times I. Now that's a 1 in the numerator, but there's a square root of 2 in the denominator, times I. So let's multiply by square root of 2 over square root of 2 to rationalize the denominator. We'll have 1 times square root of 2 in the numerator, which is square root of 2. Square root of 2 times square root of 2 is 2 times that I. Whoops, you couldn't see that. So we have this. Just take the negative out of there and put an I. This part is square root of 1 over square root of 2. That's 1 over the square root of 2, multiplied by square root of 2 over square root of 2 to rationalize the denominator. Then we get 1 times square root of 2 in the numerator. Square root of 2 times square root of 2 is 2 in the denominator times the I. Or back at this step right here, we could just inside here multiply by 2 over 2. That would work also, times the I. That's 1 times 2 is 2. So we have square root of 2 over 2 times 2 is 4 times the I. And then write it as square root of 2 over square root of 4 times the I. But the square root of 4 is 2, so we're right back to that answer again. So the square root of negative 1/2 is just square root of 2 over 2 times that I. So replacing it back into this equation, we now have x plus 1 equals plus or minus the square root of 2 over 2 times the I. We just found that. Now we want to solve for x, so let's subtract 1 from both sides. Again, we're going to put it in front, not in back, because it looks nicer. So these ones add up to 0, and we get x equals negative 1 in front plus or minus square root of 2 over 2 times the I. This could also be written as two answers like this, negative 1 plus square root of 2 over 2 times I, and negative 1 minus square root of 2 over 2 times I. So we got two complex answers. Remember, the top one, the real part of the complex number is negative 1, and the imaginary part is square root of 2 over 2. Remember that? This answer could also be written like this. You could write that negative 1 as negative 2 over 2 plus or minus square root of 2 over 2i. And then add these, and think of this as square root of 2 times I up here. And since the denominators are both 2, we could write it as negative 2 plus or minus the square root of 2i all over 2. All those mean the same. This one's not in simplest form, but all these, they're all the same. Different ways of writing it. Should we check one of those answers just to show you it works? I'll do that, I guess. So here's the original problem. Let's check one of the answers. The original problem is 2x squared plus 4x plus 3 equals 0. Let me check, let's say, that one, the negative one with the complex number with the negative. Remember, notice these are complex conjugates. They're complex conjugates. That's how the answers come out, like this with the complex answers. So we're going to check x equals negative 1 minus square root of 2 over 2 times I. So substitute it in here, 2 times that squared, replacing the x with that. Plus 4 times that, putting the answer we got in for x again. Times x plus 3. Does this equal 0? Okay, we have to square this. So let's do it up here again off to the side. See if we can fit it in here. I don't know. We'll find out. So let's try to square that up here. So foiling, we have negative 1 times negative 1 is 1. So we have 1. That's first times first. Outsides, negative times negative, that's plus. And 1 times square root of 2 over 2i, that's square root of 2 over 2i. And then insides, same thing, plus, negative 1 times negative square root of 2 over 2i, which is, again, square root of 2 over 2i, plus that. That's first times first, outsides, insides. And then last times last is negative times negative plus square root of 2 over 2 times square root of 2 over 2. And then I times I, which is I squared. And remember, the I squared is negative 1. So we have 1. These two are like terms. So you have 1, 1 square root of 2 over 2 plus 1 more square root of 2 over 2. In other words, we add the square root of 2 over 2 and the square root of 2 over 2 together. Or we can just double, but we get plus square root of 2i. You have, let me see, I don't know if you can see that, square root of 2 over 2 plus square root of 2 over 2. Factor the I out if you want, like that. That's really what that means, these two added together. It's not equal to that, but that's what these two added together is. And you can see you get square root of 2 over square root of 2, or plus square root of 2. That's 2 square roots of 2 over 2i, and these square 2's divide out. So that's how we added these two together. And then this one, plus square root of 2 times square root of 2 is 2. 2 times 2 is 4. I squared is negative 1. So that's minus 1/2. So this is minus 1/2. So we have 1 minus this 1/2, 2 over 4 reduces, plus square root of 2 times I. 1 minus 1/2 is 1/2, so we get 1/2 plus square root of 2 times I. That's what we get when we square that. Okay, so I'm going to put this, after all that work, back in for this over here. Okay, I hope you saw all that because I wasn't looking at my camera, so I don't know if it was in the screen, but there it is, all the work. This is not, that's just adding the square root of 2 over 2. I adding it to itself. That's this part right here I put over there just to show you. But that's the work. Okay, so now substituting this back in for this squared term, so we have 2 times that squared, which turned out to be 1/2, plus square root of 2i, and plus 4 times this, let's multiply it out. 4 times negative 1, that's minus 4. Make that a minus 4. And then positive times negative minus 4 times square root of 2 over 2i times x. All that, this is all times x now. So let's just, how do I want to write this? So, I could have put the 4x out here. Let's write it like this, with an x there and an x there, okay? Or, I'm sorry, there's no x. What am I doing? We substitute that in here. There's no x here. That was my mistake. So I put the x in for the number, and then I wrote it here. I don't know why I did that, but we substituted this in for the x. So there shouldn't have been an x here. So if you wrote that down or looked at that before, that was wrong. There's no x there. I don't know what I'm doing here. Okay. Okay. So we have that, and then that's multiplying this out, distributing the multiplication, plus 3, question mark, does that equal 0? Now, let's distribute this, okay? This should be, parentheses is in the wrong spot too. I'm really screwing up here. It goes there. So we have 2 times 1/2 is 1, plus 2 times the square root of 2i, minus 4, minus, this is 1/2 when it reduces, 1/2 square root of 2, or we could write a square root of 2 over 2 either way, I, plus 3, question mark, does it equal 0? Where did I screw up? I screwed up somewhere. It doesn't look like it's coming out to be 0. These two should be the same, and they're not. I messed up somewhere. What did I do? Okay, I'm going to pause it for a minute while I find the error. Hold on.